Welcome back for another mathematics discussion. This is Erwin Angelo V. Baduria, your math teacher. Our topic in this discussion is about compound interest. So, at the end of this video lesson, you should be able to illustrate compound interest, compute the amount of interest, maturity or future value, present value, and term. Solve problems involving compound interest. Just like what we did in our previous video lesson, let us define first the terminologies to be used in this discussion. First is the principal amount, denoted by uppercase letter P, which is the amount of money borrowed or invested. Amount of interest is I, that is the gain or the profit. The interest rate is the rate charged by the lender or rate of increase in an investment. Term T is the time in years when the money is borrowed or invested. The future value is the sum of the principal amount and the amount of interest. Conversion unit N, denoted by lowercase letter n, refers to the number of times the principal amount will gain a profit within a year, while the last one is a nominal rate, denoted by I subscript n, refers to the annual rate of interest which is divided by the number of conversion units. Now let's take a look at the different formula that we will be using in this discussion. First is the future value as being defined a while ago. It is the sum of the principal amount plus the interest. Followed by the second formula, which is F equal to P times 1 plus R raised to T. This formula we will be using this formula if and only if the rate is compounded once a year. Compounded once a year. Next, only one in a year. Okay. The third one is F equal to P times 1 plus I subscript n over n raised to nt. Now let me introduce a different variables here. F is the future value, P is the principal amount or the present value. I subscript n here is the nominal rate that is to be divided by the number of conversions n. The number of conversions is the number of times we will be getting an interest from the principal amount. That is raised to nt. So we will be using this formula only when the rate is compounded more than once a year. Now the last formula is F equal to P e raised to RT. This formula is a formula for compounding continuously. Okay, so we will be using only this formula if the rate is compounded continuously. Now let us start our discussion by taking up these 5 examples on the screen. So for item number 1, we have what is the interest of 13,000 pesos if invested at 3.5% compounded annually once a year in 2 years and 4 months? Determine the maturity value. So let's identify first the different values of the variables. So we have P is the principal amount or the money to be invested, which is or being invested, that is 13,000 pesos. And we have the rate R because it is compounded annually or once a year. So that is 3.5% or that is the same as 0.035. Followed by the term, which is 2 years and 4 months. This is the same as 2.33 years. Okay. So the question is, from these variables that we have, the values of the variables, what formula are we going to use? We are asked to determine to solve for the interest. We are asked to determine for the value of the interest and the value of the maturity value. So we will be using the formula F equal to P times 1 plus RT because the rate is compounded annually or just once a year. So we have F is unknown, so we have to solve first for the value of F or the future value in order to get the value of the interest. So P here is 13,000 pesos times 1 plus 0.035 raised to 2.33. Solving the quantity, the value of the value inside the quantity, we have 1.035 raised to 2.33. And then evaluating the exponent 2.33 in our 1.035, it will give us a value of 1.083455341. And multiplying these two numbers will be 14,084 and 92 cents. Okay. So we have now the future value here, the future value. But how are we going to determine the value of the interest? From our definition, the future value is equal to the sum of the principal and the interest. Okay, so we have to isolate the value of I here since we have the value of F and P. So we have F minus P. And in that case, I is equal to, our F is 14,084.92 minus 13,000. Therefore, our interest or the amount of interest will be 1,084.92 cents, pesos and cents. Okay, so that's item number 1. Now let's proceed to item number 2. So we have item number 2. Mr. De La Cruz aims to have his investment grow to 300,000 pesos in 4 years. How much should he invest in an account that pays 3% compounded annually? What is the amount of interest? So let's identify first the different values or values of the variables. So we have under number 2, we have he wants to grow his money to, so that's the future value. So F is equal to 300,000 pesos. Okay, and then we have T is 4 years. We have the rate that is compounded annually is 3%. That is 0.03. And we are looking for the value of P. How much should he invest? Okay. Then we are also looking for the interest. So in that case, we will be using the formula of F equal to P times 1 plus R raised to T. Our F is 300,000 pesos, which is equal to P times 1 plus 0.03 raised to 4. Well, in that case, we have to solve for the value of 1.03. So we have 300,000 on our left is equal to P on our right. That's 1.03 raised to 4. And then we have 300,000 is equal to P. We have to evaluate this 1.03 raised to 4. That is also already equal to 1.12550881. Now what are we going to do next? We have to divide both sides by the number beside P. That's 1.12550881, both sides. So this will become P. Now the value of our principal amount will be That's 300,000. 300,000 divided by 1.1255088. In two decimal places, it is equal to 266,546 pesos and 12 cents. That's the principal amount. That's the money that Mr. De La Cruz should invest. Now the question is, what is the interest? What is the amount of interest? Now we have to use again the formula that is F I is equal to F minus P. So we have our F is 300,000 pesos minus 266,546.12. Therefore, the amount of interest is, that's 33,000. 33,453.88. Okay, that's item number 1 and item number 2. Now let's proceed to item number 3. So for item number 3, we're asked to determine for the number of years. How long will it take 25,000 pesos to earn an interest, to earn 3,000 pesos if the interest is 9% compounded quarterly. Therefore, the formula we will be using is the formula that has a compounding rate of interest more than once a year. That's the third formula. Now, in order to do that, let's identify first the different values or the different values of the variables. We have here in item number 3 is P, which is 25,000 pesos. And the amount of interest is 3,000 pesos. We know that we know that if we add the value of I and P, we have the future value, which will become 28,000 pesos in this case. Now we have a nominal rate that is compounded quarterly, that's sub 4, that is I sub 4 is equal to 9% or 0.09. And our number of conversion units N is equal to 4. Now let's use the formula. Our formula will be F equal to P times 1 plus I sub N over N raised to N times T. Now our future value here is 28,000 pesos. That is equal to 25,000 pesos times 1 plus our nominal rate is 0.09 over the number of conversion units is 4 raised to 4 T. We are looking for the value of T. Now in order to do this, we can divide both sides by 25,000 here. 25,000 pesos. We can divide both sides. So cancel out. 28,000 divided by 25,000 is 1.12. That is equal to 1 plus 0.09 over 4 raised to 4t. After that, we can already solve the value inside the quantity. That is the same as 1 plus 0.0225. Dividing 0.09 and 4 gives us 0.0225. That is closed quantity raised to 40. And then we can add the number inside the quantity. That is 1.0225 raised to 40. Now, how are we going to solve for this? We can use the function of the logarithm. We can log both sides of the equation so that the exponent in my right side becomes the numerical coefficient of the log. In order to do that, we have to log both sides. It's 1.12 is equal to log of 1.0225, and we will be applying the property of logarithm that the exponent will become the numerical coefficient. Therefore, it will become log of 1.12 is equal to 40 log of 1.0225. Now to solve for t, we can already divide both sides by 4 log of 1.0225. We can divide both sides by 4 log of 1.0225 here. Both sides, that's 4 log of 1.0225. So cancel out our 4 and our log. The remaining variable in my right side is t. And t is equal to, if we will be calculating this in our calculator, that is already equal to 1.27 year. Okay, or we have 1 year and 3 months. Okay, let's continue our discussion in item number 4. How long would it take your money to double itself? So for number 4, we are looking for the number of years that your money, F, becomes twice of the principal. Our principal is still P. But for letter A, the case is that it is 4% compounded semi-quarterly. Meaning, in a year, we have 4 quarters, that in every quarter of this year, we will be getting twice of the interest. Therefore, if we have twice quarterly and we have 4 quarters in a year, our N will become equal to 4, to 8 rather, and that our nominal rate is equal to 4%. Now let's solve. In order to do this, we have to use our formula F is equal to P times 1 plus I sub n over n raised to nt. And that our future value is twice of the principal, and the principal will be as is. And we have 1 plus 0.04, our nominal rate, over 8, the number of conversions, raised to 8t. 8 is equal to n. N is equal to 8. Now, in order to do this, we have to cancel out p. The remaining values will be 2 equal to 1 plus 0.04 over 8 raised to 8t. And that the value inside the quantity is, that will become 2 equal to 1 plus 0.04 divided by 8 is 0.005 raised to 8t. Adding these numbers inside the quantity will give us 1.005 raised to 8t. Now, how are we going to solve for t? And in this case of the solution, we will be using the logarithm. We have to log both sides of the equation so that we can use the property in order to move down the variable t, that is raised to 8t. In this case, we have to apply the property of logarithm, that the exponent becomes the numerical coefficient of the log. So we have log 2 is equal to 8t log of 1.008. And then we can now solve for the value of t by dividing both sides by 8 log of 1.00. This is 005 rather. This is 005. 005. 005. Okay. So on our left side, that is 8 log of 1.005. So we have to cancel out this in our right side. The remaining variable is t, that is equal to, encode this in your calculator, and it will become 17.37 years. That's for letter A. Okay. Now, in this case, for letter B, it is compounded continuously at the rate of 4%. So we have to use the property of, we have to use the other type of formula, that is F equal to PE raised to RT. So let me just remove this. Okay, so our formula is for letter B is F equal to PE raised to RT. Okay, and that in that case we have F is equal to 2, 2P, and P is the same as P, but our rate is 0.04 or 4% continuously. We do not have any number of conversions here because it is compounded in continuous form. So we have F is equal to 2P equal to P E raised to R. Our R is 0.04 and we are looking for the value of T. We can now cancel out the variables P to both sides of the equation. The remaining equation will be 2 is equal to E raised to 0.04 T. Now we have to apply the second type of logarithm, which is the natural logarithm. We have to use ln to both sides of the equation so that the exponent of e becomes the numerical coefficient of the ln. When do we use ln? When we have e. We use log when we have a common numbers, except for natural numbers like e. So in this case, ln 2 is equal to, we have to bring down the exponent and write ln e. Now for continuous continuing the solution, we have to apply the property of the natural logarithm, that ln e is equal to 1. So we have ln e is equal to 1. So in this case, we have ln 2 that is equal to 0.04 t times 1. Any number to be multiplied by 1 is the same as that number. So we have 0.40 in my right side. So we have to divide both sides by 0.04 rather, 0.04. Cancel it out. So the remaining variable in my right side is t, that is equal to ln 2 over 0.04. Now, calculating this, we have 17.33 years. Now let's have the last item. Our last item is that a businessman loaned 900,000 pesos from a local bank that charges an interest rate of 7.5%. For the first question, how much is he going to pay at the end of 3 years if it was made at 7.5% simple interest? So let's solve first item letter A, so 5A. So in this case, the principal amount is 900,000 pesos and our rate is 7.5% or 0.075. The term is 3 and it is a simple interest. So we have to use the formula of simple interest, that is F equal to P times 1 plus RT. And we are looking for the maturity value or the future value F. So we have the principal amount is 900,000 times 1 plus 0.075 times 3. So we have to solve 0.075 times 3. That is equal to 0.225. Then we have to add 901 and 0.225. So in this case, we have 900,000 times 1.225. Multiplying these two numbers will give us 1,102,500. That's the future value. Okay, that's for 5A. Now for 5B, the question is that it is compounded in the same rate of 7.5% but semi-quarterly in 3 years. So still our principal amount is 900,000 and that our rate is 0.075, and that it is semi-quarterly, therefore our number of conversion units n is equal to 8. And then, what formula are we going to use? We will be using the formula of f equal to p times 1 plus I sub n over n raised to nt. This is a compound interest that is compounded more than once a year, and that we have our term is 3 from the given item. That's letter B. So we have to substitute the values. So we are looking for the value of f. So f is equal to 900,000 pesos times 1 plus 0.075 over 8 raised to 8 times 3. So we have 900,000 times 1 plus, that's 0.075 divided by 8 is the same as 0.009375 raised to 24. That's 8 times 3. Now to continue this solution, we have 900,000 pesos, and then we are going to add the numbers inside the quantity, that is 1.009375 raised to 24. And then let's evaluate the power of 24 from this 1.009375. So we have 900,000 pesos is to be multiplied by 1.251010,792. And multiplying these two numbers will give us 1,125,909.71 pesos. So the value that the businessman should pay at the end of 3 years in compound interest, compounded semi-quarterly, is 1,125,909.71. Now for 5C, according to the problem, it is 7.5 compounded continuously. So we will be using the formula, the last formula, that is f equal to PE raised to RT, because this is compounded continuously. Okay, so our F is our P is still 900,000 pesos. Our rate is, it is provided 0.075, and the time is 3 years again. So we have F is equal to P, which is 900,000 pesos, to be multiplied by E raised to 0.075 times 3 times 3. Oh, let me rewrite it again. So we have e raised to 0.075 times 3. Now let's evaluate the exponent 0.075 times 3. So multiplying these two numbers will give us 0.219, and then we have to evaluate in your calculator the value of e raised to 0.219, and that will be equal to 1.244831,277. Then we have to multiply these two numbers, and it will give us 1,120,348 pesos and 15 cents. So for compounded continuously, we have 1,120,348.15. Now if you are going to observe in our answer a while ago in our simple interest, our F is equal to 1,102,500. Now observing the these values, you will notice that compounding more than once a year will give us a larger value or larger amount of future value, instead of using simple interest and compounding continuously. So that ends our discussion of compound interest. For your practice, answer the following items shown on the screen. Number 1, what is the interest of 5,000 pesos if invested at 3% compounded annually? In 2 years and 6 months, determine the maturity value. Number 2, Mr. De La Cruz aims to have his investment grow to 700,000 pesos in 3 years. How much should we invest? How much should he invest in an account that pays 4% compounded annually? What is the amount of interest? How long will it take 23,000 pesos to earn 7,000 pesos if the interest is 5% compounded quarterly? How long will it take your money to quadruple itself if it is invested at 5% compounded semi-quarterly? And for letter B, if it is invested at 5% compounded continuously. And for the last item, a businessman loaned 250,000 pesos from a local bank that charges an interest rate of 9%. Letter A, how much is he going to pay at the end of 5 years if it was made at 9% simple interest? For letter B, how much is he going to pay at the end of 5 years if it was made at 9% compounded semi-quarterly? And letter C, how much is he going to pay at the end of 5 years if it was made at 9% compounded continuously? If you have any question or inquiry, do not hesitate to message me or just have a comment below. Enjoy! To end this discussion, let me leave you this real-life lesson. Give your large interest to things that make you grow intellectually, professionally, spiritually, and psychologically. With that, see you in our next video lesson. Have a great day!